Hey everybody, my name is Rahim Ibrahim. I'm the Director of Technology Alliances here at Zscaler, and I'm here to talk to you today about how Zscaler and Sumo Logic work together to deliver zero trust and visibility. So if you're not familiar with Zscaler, I'd like to share a couple of things with you. Zscaler was founded about 12 years ago. We had the knowledge that security had to transform with companies adopting technologies like SaaS and cloud. We've pioneered the highly scalable zero trust exchange platform that sits in over 150 data centers across the world. And this zero trust exchange platform connects users, devices, workloads across or over any network, essentially. We are a leader in zero trust, and we are recognized by Gartner as a leader in the Secure Web Gateway Magic Quadrant, as well as the Secure Services Edge Magic Quadrant. We have over 12 years of experience running the world's largest security cloud. Today, we protect over 5,600 customers across the globe and see over 240 billion daily transactions. Our customers include among the largest companies around the world across all verticals. Some proof points from our customers. We help NOV. NOV is a company in the oil industry, and we help NOV be more secure. Before they adopted Zscaler, they were constantly re-imaging their machines due to infections. After deploying Zscaler, they saw a 35x reduction in this activity. With ESG, we help them reduce complexity and cost. With another industrial organization, we help them free up their security team's time. This time was actually moved away from low-level tasks, which were critical but not important, to high-value ones. We've helped companies essentially reduce their business risks, reduce their costs, and deliver a better user experience. So let's talk a little bit about how the traditional networks and traditional security in your environments today, and in the environments you see today across the enterprise. So traditional networking in an enterprise started and evolved from a hub and spoke network. In this hub and spoke network, branches and users connect back to the data center. In the data center, there are stacks and stacks of appliances that each branch or site connects back to. To reduce latency, expensive links are deployed from different sites to regional data centers. So all this worked reasonably well in the pre-cloud era when the data center was the center of gravity. However, as you all know, the technology we use and the way we work today has changed. Applications are being modernized, and they've moved outside to the internet. This is really what we call as application transformation, adoption of IaaS, PaaS, and SaaS. Now, with apps in the cloud, branches and employees want to go direct to the internet to get access to the data and apps they want to use. This means that branches need to transform, and users still need to be protected. This is the network transformation part. Instead of the hub and spoke, branches and users want to go direct. Because of network transformation, what happens is you will also need security transformation. So it doesn't make sense to deploy appliances at each branch to mirror that same level of protection you have in the data center, because that would just be explosive cost. It doesn't make sense to reduce the amount of protection for each branch, and also how would you secure the remote users, right? Nobody wants to VPN in. Everybody wants to go direct. Everybody that's working from remote locations, they've moved outside the offices, outside of the network perimeter. We need to secure them. Branches are doing local internet breakouts and to get better experience by going direct into the internet. So because of this is driving the need for a security transformation. And security transformation is really moving away from that castle and moat technology into a zero trust architecture that I'm going to talk to you about. So before we dive into the zero trust architecture, let's take a quick look at some of the risks from a hub and spoke in a cloud first world. So branches, as you know, as I mentioned, extend the network from the data center to the office. Remote users getting access to apps are required to VPN into the data center. With VPNs, what's happening is you're extending your network to all users across all locations. So just think about that for a minute. If you've got 10,000 users, you've extended your network out to 10,000 different locations across the world. Infrastructure in the cloud is also extended using firewalls and site-to-site connectivity. Each of those branches and access points are secured with firewalls and VPN concentrators. These provide attackers targets and increase your attack surface. Now, as users go out direct to the internet, they want to bypass the VPN because who can blame them? Slow performance. They don't want to hairpin back into the data center. By bypassing the VPN, they have essentially possibly allowed malicious content to sneak through. Once an endpoint gets infected, threats can move laterally across the network and spread across the entire network. In fact, if you remember the NotPetya case with Maersk a long time ago, 3 years ago, this is essentially what happened. Data can then be exfiltrated, sent to cloud file services, encrypted, and then bypassed. Detections all bypassed. To summarize, extending your network increases your surface area, your attack surface area, and therefore increases your risk. Attackers bypass the traditional defenses, and these attackers are getting more and more sophisticated. Users will be attacked via things like phishing. They attack infrastructure via misconfigurations or unpatched machines. VPNs and firewalls present themselves as targets. Once a breach occurs, attackers tend to move laterally to exfiltrate data, demand a ransom, or even worse, lurk in the background. Complexity is an enemy of security, and this patchwork of consoles and point products allows threats to go undetected or not responded to. So, to summarize, this complexity is definitely increasing the threat landscape and the risk to our companies. Now that the perimeter has dissolved, taking the same approach of the castle and moat technology and architecture no longer makes sense. The focus has shifted to protecting users and data rather than the networks. Companies are beginning to use the internet as the corporate network, no longer backhauling to the data center. A zero trust architecture dramatically simplifies how you connect users to resources. Adopting zero trust, you can retire dozens, or if not more, of networking and security point products to reduce cost and complexity. Instead of a mesh legacy infrastructure architecture, all you need is a device and internet connection. Every employee becomes a branch office of one from any device or any location. Remote users are connected by a lightweight agent on the endpoint, and they connect up to the Zscaler. This approach delivers better cyber threat protection, faster user experience, and better agility. So let's see how Zscaler for users protects users connecting to the internet and their private apps. So Zscaler provides the full security stack in the cloud. It's always on, it's always available. Users working from home or the coffee shop are connected from their laptop, their phone, tablet to the Zero Trust Exchange. Entire branches are protected because the entire site's traffic is sent to the Zero Trust Exchange. So the Zero Trust Exchange provides the full cybersecurity stack, including SSL inspection, malware detection, antivirus, malicious URL, policy, app control, sandboxing, you name it. The list keeps going on. These engines, all these different types of security engines, operate as one and in parallel in the Zero Trust Exchange. All this parallelism provides fast inspection of traffic. Zscaler also provides secure access to private applications, whether they're in the data center or the cloud. So a common use case for this is VPN replacement. These apps are connected through the Zscaler Zero Trust Exchange, and this connection makes them invisible to the internet, eliminating one big attack surface. After all, you can't attack what you can't see. With Zscaler, users are connected to apps. Users are not connected to the network. This eliminates lateral movement. Because Zscaler is in the exchange through which all your traffic goes through, we really have unparalleled visibility. Zscaler sees where the bottlenecks are, and in the network or in the internet or apps, we can provide you the root cause and proactively resolve issues before tickets are filed. Zscaler for users is really easy to deploy. With a common agent on the endpoint, you can connect to the internet and the private apps securely all the time. You don't have to turn off your VPN or turn it on. You don't have to figure out when to turn it on or off. Security is always on, and we connect you to the private application seamlessly. Zscaler reduces cost, complexity, and we eliminate appliances. Our customers save on not needing to manage hardware or virtual machines. You don't need to install anything, manage, or maintain. Never trust, always verify. That's how Zscaler works. Zscaler Zero Trust Exchange connects users, workloads, IoT, OT seamlessly and securely. To accomplish this, we follow 5 steps. Number 1, we terminate the connection. So we determine who you are. Number 2, we determine where you're going, specifically what app you're trying to access. Where is the internet destination? Or if you're an IoT device, what are you trying to access? We assess your context, your who are you, where is your location, what kind of device type you're trying to use, and what's your posture. Posture means things like, is your antivirus running, is your EDR running? This is all used to determine the level of risk that you present. Third, we execute inline inspection of both encrypted and unencrypted traffic. Make sure you're not carrying any malicious content, any malware, or harmful payloads. Now, this inspection is really done at scale, and nobody else can quite do that. We can decrypt all your customers' traffic and run it through multiple security engines in parallel, as I mentioned earlier. If everything looks good, we then establish the connection. Unlike traditional network security based on firewalls and VPNs, we don't allow pass-through connections. So compromised users or encrypted threats cannot access your assets. By applying a risk-based policy, we dynamically deny access to risky users. We block sophisticated inbound threats like ransomware and also inspect outbound traffic to enforce data loss prevention policies. Finally, to eliminate lateral threat movement, we connect users to an app, not the network. Zscaler eliminates that attack surface, as I mentioned earlier, by having the app make a connection to Zscaler Zero Trust Exchange. This means it doesn't respond externally to any probes or pings. We essentially made it invisible. So I'd like to share a common attack sequence. Number 1, attackers look through your attack surface. They recon your environment by looking through for exposed things like exposed assets. They perform an initial compromise. This is performed by things like phishing links or malicious content which people download. Once they've gotten a beachhead, they explore. They perform lateral movement, planting malicious code, looking through assets, creating backdoors. Once they're settled nicely in their new home, they start moving data out, stealing information, records, precious data, and then encrypt it all, demand a ransom. This is a common sequence, and it can be stopped. An exploitable attack surface, initial compromise, lateral movement, and data loss. So how does Zscaler stop this same movie from playing over and over again? First, through Zscaler Zero Trust Exchange, we eliminate the attack surface presented by VPNs and firewalls. We connect users directly to apps and make those apps invisible to attackers by putting it behind the Zero Trust Exchange. Second, our platform prevents initial compromise through a set of capabilities. These include things like rendering email links as pixels through our technology like cloud browser isolation, as well as inspecting all traffic inline, including encrypted traffic. We block day zero threats by sandboxing files. Third, don't put users or workloads on the network. Instead, create connections through the Zscaler platform. This eliminates lateral threat movements, preventing attackers from snooping for high-value assets. As an added layer of protection, we have a technology called Zscaler Deception that puts decoys through your environment to trap any attackers and stop further progress. Finally, our cloud data loss prevention, CASB, and workload protection capabilities help you apply policies to stop data exfiltration and malware delivery across your organization. So these common methods of finding an exploitable attack surface, that initial compromise, lateral movement, and data loss can be stopped. So Zero Trust is a team sport. Zscaler is focused on sitting in line to secure users and workloads. We partner with leading vendors in each space so that it's easy to integrate with your existing tools. Our integrations leverage open APIs that are published. so partners can provide automation and visibility into our platform. For example, in the SD-WAN space, we have automations that set up connections easily with a single click. In the operations space, we partner with folks like Sumo Logic, where we provide logs so that hidden threats or automation exercises such as threat hunting can be easily performed. So while Zscaler provides enforcement, we rely on partners like Sumo Logic for analytics. Sumo has been an innovative Zscaler partner and has developed integrations such as log ingestion across our portfolio. One key differentiator is that both our platforms are SaaS services. Zscaler is able to send our logs to Sumo using several different methods. Recently, we introduced something called Cloud NSS. With Cloud NSS, you can connect basically two platforms, our cloud platform with another cloud SIM directly without any appliances. Sumo Logic was one of the first integrations to develop this. This is important for customers looking to move away from appliances and adopt cloud. Sumo has also developed an application where logs are transformed into dashboards for faster data visualization using the telemetry that we send. While the logs are always available, these visualizations can really help to quickly determine directional status of an environment. Sumo also has integrations with our APIs to automate actions and responses for faster remediation. Examples of the sort of integrations that Sumo has done is adding malicious URLs and IP address to our block list. Other examples can be more interesting, such as performing repetitive tasks like threat hunting, and this can involve going through historical logs to find any lurking threats in your environment. With that, I hope you've had an informative presentation. Feel free to reach out. My email address is back there on the first slide, and let me know if you have any questions. Thank you.